In this lesson, we're going to go over some applications of linear equations. Specifically, we'll apply the slope and the y-intercept to application problems. So, modeling using linear equations or applications of linear equations, what I recommend is determining the starting value or the starting point. In our y equals mxb formula, this would be considered b. Determine the rate of change, this would be considered our slope, and then the equation that you'll write would look like y equals mx plus b with whatever variables are given. So sometimes they'll have you use p or v or y, but essentially the same thing is happening. You're determining the starting point and you're determining whatever's changing. Keep in mind, if it's increasing, it's positive. If it's decreasing, it's negative. Okay. So first example here, the cost in dollars of driving a rental car X miles is given by C of X is equal to 1.60X plus 40. Don't get too tripped up by the C of X. That just means cost is a function of X or is a function of miles. The important thing here is that C represents cost and X represents number of miles. Okay, what is the slope? So you use slope-intercept form. Okay, the number in front of X is the slope, and in this case it's 1.60. What does it represent? We're talking about cost of driving the car X miles. Cost is playing the role of Y, miles is playing the role of X. So this means that it costs 1.60 or $1.60 per every mile. Okay, so that would be the interpretation of the slope. So if you drive 1 mile, you pay $1.60, another mile you pay another $1.60, and so on. What is the y-intercept? The y-intercept is the number by itself, is 40, okay, and the y-intercept is our starting point. So think about what that could mean in the context of leasing a car. It means that you're going to pay $40 whether you drive the car 5 miles or 10 miles. Your starting point is exactly that. It's your starting point. It does not depend on how many miles you drive. There's no X by it. Okay, so this is the starting or initial amount to rent the car. Okay. And so how far could you drive if you only had $112? Well, in this case, 112 is cost, so you would plug that in for C. So you'd have 112 is equal to 1.60x plus 40, and then solve for x. So we'll subtract 40 from both sides. Which is 72. So we have 72 is equal to 1.60x, and then divide both sides by 1.6. And so x should be 32.5. And so what that means is if you have $112, you could only drive 32.5 miles. Okay. Number 2, if you drive 400 miles, what would the cost be? So in this case, it's giving us x and it's looking for C, or for the cost. Okay, so our cost would be equal to 1.60 times 400 plus 40, and if you plug this into the calculator, you should get $680. Okay, so notice that this is in the form of y equals mx plus b, but the rate of change is taking on dollars per mile, and then the cost is how much it's the cost to drive a rental car. Okay. Example 2, a $20,000 car depreciates by $4,000 each year. Find a function for the depreciated value of the car as it varies with time. When does the depreciated value reach 0? So I'm going to do this one 3 ways. The first way is we're going to talk about what's happening and just go through year by year. The second way, I'll write an equation y equals mx plus b, which you will have to know how to do. And then the third way is I'm going to show you what this looks like on a graph. So no matter what type of learner you are, hopefully one of these 3 ways will help you understand what's happening here. Okay, so our starting value is $20,000. So let's say you buy a car January 1, it's $20,000, and by the end of that year, it depreciates $4,000, which means it loses value. So depreciation means it loses value. So that's a negative rate of change. Okay, so at the end of year 1, our car is $20,000 minus $4,000, which is, its value is $16,000. Okay. At the end of year 2, you can either take 16,000 minus 4,000, or because I'm building y equals mx plus b here, minus 4,000 times 2, because now we're at the end of year 2, it's depreciated $4,000 2 times. So this would be $12,000. You keep going, year 3 times 3, which would be $8,000. Okay, you can probably see what's happening here. at the end of year 4, if you wanted to use the 8,000, and then year 5. So 4,000 minus 4,000 equals 0. So to answer the question, when does the depreciated value reach $0? At the end of 5 years, or 5 years. Okay, so this is how to kind of think through what's happening with the mathematics of this problem. And the next slide will go over what the equation looks like. So when you're building an equation, y equals mx plus b, or what I'm going to say is that our value is equal to our rate of change times the number of years plus b. Okay, usually the software or in like a mini project or test, we would tell you what letters to use. Okay, but it's the same. You have a rate of change and you have a starting value. So in this case, our starting value is $20,000. Okay, that's what the car started off as. And then we have rate of change language here. Dollars per year is what's changing. Something per something else usually denotes slope or rate of change. So our slope or our rate of change is going to be negative 4,000. Okay, so you could put this into an equation. V is equal to negative 4,000 x plus 20,000. Okay, and then to answer the part of when does the depreciated value reach $0, you would plug 0 in for the value and solve it for x. Okay, move the 20,000 over, divide both sides by negative 4,000. The reason we know to plug 0 in for value is because that's what we're looking at here. And so when you're determining whether to plug 0 in, it's either the y or the x. In this case, x is number of years. That's why I put a y in that spot. And so the 0 would go in for the value. Okay. And then lastly, you could draw this out on a graph. So we're starting at $20,000. That's the initial value. And we decrease by 4 values every 1 year. $4,000 every 1 year. Pretend these are in thousands of dollars. Decrease by 4,000 every 1 year. Keep going. And when does it reach 0? 5 years. Okay, so again, whether you like graphs, like algebra, or like to think it through, there's 3 different ways to approach that problem. Example 3. A car can be purchased for $16,000 or leased for a down payment of $2,000 plus a monthly fee of $1,000. Find a function that describes the cost of the lease, assuming the monthly payments are made. How long can the car be leased before more than the purchase price has been paid? Okay, so there's a couple different things going on here. Start with part 1. Find a function that describes the lease as it depends on time. So when you're finding a function that describes the lease, you're only looking at the numbers that pertain to the lease, which are lease for a down payment of $2,000 plus a monthly fee of $1,000. Okay, I know it says a car can be purchased for $16,000. We'll actually get into that in the second part of this problem. Okay, so our lease is going to equal some slope times the number of times the number of months. Oops. Let's just put x plus b. So for our lease, our starting value is $2,000. Down payment is a starting value. You're paying that $2,000 no matter how many months you lease this car. So that would be b. And then we have monthly fee of $1,000, or translate that to $1,000 per month. That's language of something per something else, which would be m, or the slope. Okay, so we have our lease would be equal to $1,000. Positive because you're paying more and more each month, plus 2,000. Okay, so this is our function that describes the cost of the lease as it depends on time. If you lease the car for 1 month, x would be 1 and you'd pay $3,000, and so on and so forth. Okay. For the next part of the question, let me rewrite the equation. Assuming that the monthly payments are made, how long can the car be leased before more than the purchase price has been paid? So what this is asking is, when does the lease price equal the purchase price? After how many months? So you could go through this similar to the last problem where you'd find x is 1, x is 2, x is 3, and so on and so forth, and see when you get to $16,000. Or we want to know when the lease price is the same as the purchase price, so we would plug 16,000 in for L, and solve for x. Okay. So subtract 2,000 from each side. So we'd have 14,000 is equal to 1,000x, and then divide both sides by 1,000. And we would end up with x is equal to 14 months. Okay. So on the next slide, I'm going to show you a graph of this. So let's use purple for purchase price. So purchase price is 16,000. So if this is months and this is thousands of dollars, if you purchase the car, you've paid $16,000, no matter if it's month 1 or month 2 or month 200. You paid $16,000. That was the price. Okay. The lease I'm going to do in green. So we start off at $2,000, and then it's $1,000 per month. So I go up $1,000 over a month, up 1,000 over a month, and I keep going. Right, and where these two meet is where the price is equal. So that's at 14 months, just like we found. And so after 14 months, you see how the green line is above the purple line? After 14 months, it's more expensive to lease than to outright buy the car. And these types of functions are really cool. Like if you're comparing internet plans or cell phone plans, you can graph them like this and determine at what point would something be cheaper. Let's say you are in your first semester of college and you want to rent a car or lease a car for your first semester and then maybe buy a car the next semester. Well, you could determine if that would be cost effective or not by graphing it out. In this instance, it's cheaper to lease the car for the first 14 months. So with this deal, if you intend to lease it for less than 14 months, or if you intend to use it for less than 14 months, whatever the case is, the green line is under the purple line, and so that would be cheaper. However, if you're planning on leasing a car for 2 years, well, you might as well buy it. It's going to be cheaper in the long run that way. Okay, so comparing two things like that using a graph could be really useful. Please let me know if you have any questions.